All right, happy Friday. Welcome back to PCM 6.1. Today we're going to talk about section 6.1 linear and nonlinear systems of equations. And yesterday we focused on substitution, elimination, and so forth. Today we're going to focus on the graphing portion of that. So without further delay, we'll get kicking here. It's only about 6 slides, so we'll go pretty quick. So this first one is linear equations, something that should be right in your wheelhouse here. Our first equation, which hopefully you see here, is the one I did in red. We're going to solve this for y, get into slope-intercept form. So you can see my y-intercept is 2 right here, and then I have my slope of 2/3. So I did a couple points. Make sure when you do these, you graph your line, make it the length or pretty close to the length of the whole graph, because that'll make it easier when you have your intersection points. Second graph, pretty close to slope-intercept already. It's in standard form again. We just kick that x to the other side. And now I've got a y-intercept of 7 and a slope of -1. And so when I graph multiple points with each line, I can see that our intersection point here, our solution, is this point 3, 4. So again, system of equations, especially linear equations, saw this in second semester Algebra 1. I know, again, you did it last year in advanced algebra, so this part here should not be new. Now, most lines cross. Every once in a while, you'll get two that don't, and that's what we see in this next example. Again, just to piggyback on this one real quick, if the slopes are different, you're going to have two lines that intersect. All right, slide 3 here. Almost said number 3, but slide 3. Again, this is in standard form. We're going to get that into slope-intercept form, and when we do, you can see we have a slope of 2/5, y-intercept of -2. Notice equation 2 also has a slope of 2/5. So two lines with the same slope, different y-intercepts, no shock here. They are parallel. Now we have no solution. They don't have any common point. While they do share the same slope, they don't have any time where they are at the same point at the same time. So no solution for parallel lines. So again, that's two of our 3 possibilities. So again, different slopes, they're going to cross. Example 2 here, same slopes, they're going to be parallel. And then the third possibility, when you're talking about two linear equations, they can end up being the same line. And so what you see now with this third one, and we're in standard form, so I'm going to solve that for y. I've got a slope of -4/3 plus 5. So you see positive 5 down 4 over 3. So you see the red dots here, and that's for this equation. For equation 2, when I divide by -6, we end up with the exact same thing. So again, I've got a y-intercept of 5, slope of -4/3. So you see they have all these points in common. Because it's the same line, now we have infinitely many solutions, which I just abbreviate as IMS. So again, just to recap from a linear standpoint, one option, if you have different slopes, they're going to cross, they're going to have one intersection point. If you have the same slope and different y-intercepts, they're going to be parallel, and that's going to be no solution. And if you have the same slope and same y-intercept, in other words, the same equation, it's going to be infinitely many. And so you'll see a few systems of linear equations today in your homework. Last two will be examples where you don't necessarily have two linear equations. Starting off here with two circles. So we saw this a little bit earlier in the year. It's been a few weeks, so you may have forgot. Equation of a circle, h and k is the center point, and r is your radius. So our first equation right here, x plus y squared equals 36. We got a center point, since we're not subtracting anything from x and y. Center point at 0, 0. And our radius is 6. So when I graph this circle, I got my center point at 0, 0. I went up 6, down 6, right and left 6. So that'll give me enough points to make that circle. Obviously, I have the benefit of the smartboard where I can just imprint a circle other than freehand in it. The idea, obviously, is to try to make it as best you can. Equation 2, you got x plus 4 squared, y plus 2 squared. So my center point, again, it's the opposite of this. So it's -4, -2. So there's my center point with a radius of 5. So again, up 5, down 5, right 5, and left 5. And so when I make this second circle, you can see that we have two intersection points here. And that occurs at -5, 3, and -1, -6. So when you got linear equations, you're going to have one solution, none, or many. When you have nonlinear equations, it can vary. In this case, because these circles intersect twice, you have two intersection points. If they were to just touch at one spot, you'd have one. If I were to take this circle and move it over here, we'd still have two. We could, play around with this and potentially, get more spots, or if we had a bigger circle where it intersected more than twice, but we'll leave it like so for now. Got one final example for you, and that is going to be a parabola and a linear equation. This one will also have two solutions. So you know how to graph parabola. This is x squared. Typically it'll open at 0, 0, but this one was 3 units, so we start right there. And we have our x squared parabola. My second equation is linear right here. It's already in slope-intercept form. So I've got 5x minus 1. So here's my y-intercept at -1, slope of 5, up 5 over 1, up 5 over 1. If I keep going, I'm going to have another point up here. It's off our graph, but that's going to be our second intersection where this line hits this parabola again. Now, you can kind of count it out and do it that way. The other way, just set the two equations equal. So if I put x squared plus 3 equal to 5x minus 1, I can solve. Why can I do that? Because both of these things are equal to y. And if both equations are equal to y, then they have to be equal to each other. So 5x minus 1 equal to x squared plus 3. I'll get everything over to one side. Now I got a quadratic that I can factor. And when I do that, we can see that x is 4 and x is 1. So I have my x coordinates of my intersection. And now I can plug these x values into either equation. I'm going to plug it into this linear one here because it's going to be easier. So 4 in for x right here. And I find out that y is 19 when x is 4. And y is 4 when x is 1, which coordinates with our 2 points here. So we can see 1, 4. And if we were to continue this here, we would end up at 419 for our second intersection point. So that's our systems of equations solved by graphing today. Again, this should give you enough to be dangerous and be able to complete today's homework. And we'll see you on Monday.